All right, well, hello, ladies and gentlemen, and welcome to the Intermountain Industrial Assessment Center video lecture series. Today, we're going to be giving a broad stroke introduction to the IAC, what we do, how we do it, and who we do it for. So before we get into that too much, I do really want to reiterate why we're doing this. The primary purpose for this is for guidance. In these assessments, there's a lot of moving parts. And particularly when you're new, it can feel kind of overwhelming. It's easy to get lost in what you're doing. So we really want to give you a roadmap to the assessment process so that you have an idea of where you're at in the process, what's coming next, so that you can focus on the task in front of you and that you can get it done well. Additionally, whether or not you guys like this, you are going to have to interact with a client at some point. And having this information in your mind makes it a lot easier to provide them your purpose for doing this and to just give you the confidence to speak to them. And lastly, there's a lot going on at the IAC, and it's always good to have resources, whether that be online technical documents or people like myself and your peers that you can reach out to and lean on when you need it. So that's why we're giving this presentation, and we hope you enjoy it. So to start, a little bit of history about how the IAC began. Now, the history is kind of complicated, so I'm going to do my best to summarize this for you guys. But in the 70s, there were a lot of Arab countries that decided they would try to invade Israel. And Israel has been and continues to be our ally to this day, so we provided them some military and economic support. And as it turns out, the invaders did not appreciate that. They were quite frustrated with the United States. So they got together and formed a coalition, and they were able to raise the price of oil artificially. And this is known as the oil embargo of the 70s. And this was meant to punish the United States, who was heavily reliant on oil from other countries. And it sure did the trick. Energy prices skyrocketed. And this really hurt the manufacturing sector of the United States. A lot of manufacturers worked on slim margins to begin with, and seeing increases in costs like this really hurt a lot of businesses and it put a lot of them under. So much so to the point that in 1976, the Department of Commerce created the Energy Analysis and Diagnostics Center, or what we now know today as the IACs. And its purpose was to help out American manufacturers and keep them competitive by cutting back on any unnecessary costs and inefficient energy usage. This is kind of interesting. I would like to mention that the IAC actually predates the Department of Energy. The Department of Energy wasn't created until the following year in 1977. And the year after that, for whatever reason, they decided that we fit better in there. So the Department of Energy later acquired the AEDC. So since then, our purpose hasn't changed too much, but we have expanded to focus on things such as implementation of energy management systems, cybersecurity as technology has developed, and additionally to focus on research, particularly on energy saving mechanisms and energy production. And last, just because I think it's good to know who you're working for, it's administered through the Advanced Manufacturing Office under the Office of Energy Efficiency and Renewable Energy. So just to reiterate, our mission has not changed a lot. Our purpose is to increase the U.S. manufacturing sector competitiveness by providing no-cost technical services. So to put it simply, our job is to provide a no-cost energy assessment to small and medium-sized manufacturing enterprises. And I'll get more into that in a few slides here. But basically what we're doing is we're looking for energy saving opportunities. These are projects that the client can do on their own that will help save them money in some way or another. Now, to be clear, we are not an engineering design or project management firm. We do not oversee the application of any of these projects or their implementation. We simply provide it to our customers for them to pursue on their own. Now, in everything we do, there's a whole lot of benefit to the business. First off, there's no cost to them whatsoever. We are entirely funded by the Department of Energy. All they have to do is provide us some time and some of their interaction. Additionally, there's no contractual obligation for them to do anything. So really, there's no risk for them to perform these assessments. They either like what they have or they don't. In the end, it didn't cost them any money. And one of the last benefits that I think is often overlooked is the fact that this is entirely confidential. And that's really important to a lot of businesses. For instance, let's say that a business is looking to buy a new boiler or a new air conditioning system, and they tell us that. We keep that information confidential. That way they don't get swarmed with all these vendors trying to sell them things that they really didn't want in the first place. So confidentiality, among others, is a huge benefit to businesses.
So one of the biggest advantages of working at the IIAC is that we're part of the national IAC program. And so this means that apart from having a center here at the U, we have a number of centers across the country. And this is definitely something we can leverage to our advantage, both for our academic and professional growth. We regularly have events where we actually network with other students from other IACs so we can get to know each other and do some professional networking that way. And then we also have their access to the professional resources through our box. So if you actually go onto our file sharing service box, you'll see that we actually have a number of files from these different IACs, whether it be past ARs, past resources to help identify just any energy saving measure in general. That's going to be all on box. So definitely a good advantage of being in the IAC program. And to help progress our growth in the IAC, we have our professional advisors / bosses. So Dr. Cody Powell is the director of the IAC program. He's a professional professor in the chemical engineering department, and he does a lot of work in energy systems, machine learning, AI, that kind of stuff. So really cool research that Dr. Powell conducts. Then as co-director, we have Julie Sieving, who's a professional engineer with many years of experience in the consulting world. And then we also recently got Ed Mignon, who is our project engineer, and he has a specialization in water resources. So all three are really good resources to reference when we're working through our assessments. And as new students, you'll be working with them quite a lot. Apart from those professionals, we also have a number of graduate students. Since we're on here, I think there's plans to acquire more. And then we also have undergraduate students, which the most of you new hires will be. So we have a number of new hires, typically 8 to 12, though with you guys joining on, there might be more.
All right, so hopefully at this point, now that you know who we are, you're wondering, well, who do we work with? So we work predominantly with small to medium-sized manufacturers. And again, this is mostly manufacturers we work with. You're probably wondering, how do we quantify small to medium? Well, we have several criteria that our customers need to meet to be able to work with us. The first one being that they have to spend at least $100,000 in annual energy expenditures, but they can't spend any more than $2.5 million. Additionally, they have to have less than 500 employees per plant, and they cannot make more than $100 million in gross annual sales. Now, the reason for working with small to medium-sized enterprises is we're really not supposed to work with the Coca-Colas or the Northrop Grumman's of the world. Those are large corporations that already have the resources, the time, and the money to look for energy saving opportunities like this. And that's an expectation that they should be held to. On the other hand, small to medium-sized manufacturers really don't have the time or the resources to look into this sort of thing. So our goal is to step in and help them increase their competitiveness by doing these things that they otherwise wouldn't have the time or opportunity to do on their own. So there are some asterisks in there that I would like to address. Because we're funded by the Department of Energy, we do often work with institutional customers. This could be schools and universities. However, more typically we work with water treatment facilities and water distribution plants. And that's mostly for the professional development side. That's for your professional development. Additionally, you'll notice that we use the phrase per plant a lot when talking about that small to medium-sized criteria. Often we will have customers that meet most of those rules, but they fall short in a few places. So what we can do is we can actually split an assessment in half and work with 2 different plants that meet all of those criteria. So those are the exceptions that you will typically see. Now, just to give you guys an idea of just who we're working with and how big of an impact we have, you can see here a list of all of the manufacturers here in the United States. You can see their industry, the total number, and on the far right side, what we would consider to be a small to medium-sized manufacturer. And at the bottom, you'll see this represents over 90% of the manufacturers in the United States. So we really do have a great impact on the economy and the manufacturing sector. We work with a lot of people. We are not isolated in any sense. So getting more into the juicy part of this presentation, we're going to talk about the assessment process. And it can effectively be broken up into 4 sections: the pre-work, the plant visit, the analysis and write-up, and the follow-up. So we're going to go through these one by one. So the assessment process begins with the pre-work, where we reach out to the client and we try to schedule a visit. We see if they're interested. And if they are, we schedule a visitation date and we ask them for 1 year's worth of utility bills for us to evaluate. And this is incredibly important to look at their electrical, gas, and water consumption. As you guys will learn, it's amazing how much you can learn about a facility just by looking at their utility bills. After we've scheduled the assessment and gotten their information, we hold a pre-assessment meeting. And at this point, the team lead is going to talk to the team about the facility, what they do, and just try to give them a general overview. Additionally, they'll talk about plant equipment, and they'll typically assign people to do research on this equipment and try to find optimization techniques. And this is really important because if we can go into a plant knowing what to look for, then we can already have a few ideas in mind, or alternatively, if they're already doing those things, we have things that we can congratulate them for doing and that we can encourage them to continue doing in the future. We really do like to see people already doing the right things. So the plant visits typically take place over 1 day. Occasionally you'll see it spread out over 2, but for the most part, they always follow the same routine. And that is in the mornings, we typically meet with the plant management and learn about the facility. And this is super crucial. You know, these people work in the plant day after day, year after year, so they know the operations better than anyone. I mean, facility staff are a great resource that you should always talk to, and you always want to hear what's important to them and what they find to be valuable, especially since they're the ones who are going to be reading the report and who you have to sell the ideas to. So you have to make sure that you're on the same page. This is often followed by a plant tour of the process and the equipment, where we actually get to see it for ourselves and see how it matches up to what we had imagined. Next comes my favorite part of the plant visit, and that is lunch. And you do get a free meal. It is paid for by the IAC, but the focus of lunch is mostly to brainstorm ideas, or what we call assessment recommendations. Here at the IAC, we have our own lingo. You will hear the term AR thrown around a lot. And that is simply these ideas or these energy saving opportunities that we'd like our clients to pursue. So don't be intimidated by the phrase ARs. You're going to get quite used to them. So after we kind of have this collection of ideas that we'd like to look into, we spend the last half of the day actually going around and collecting the information. And this involves taking measurements, photographs, And again, talking with facility personnel, they know these places like the back of their hands, and you can usually learn everything you need to just by talking to them. But again, the main focus is to just get any and all information that we might need to estimate how much our ideas will save them. Just to give you guys a glimpse into some of the recommendations we like to provide, we got some bread and butter items, such as replacing fluorescents with LEDs or HVAC set points. For instance, we could say, oh, your thermostat is set way too high. Just turn that down a little bit. You'll save a ton of money. One that we work with on almost every plant visit is compressed air leaks. We also like to look at variable flow drives on pumps and compressors. And then for hot water transportation or steam transportation, we look at boiler tuning, steam trap surveys, steam leaks, and condensate return systems. And if none of that makes any sense to you, don't worry, soon enough it will. Some of the more advanced measures that you don't see as often, but you certainly do see, is smart building automation. That's where you purchase a computer system that runs your building in a way that it's energy efficient. We also like to look at energy storage. This can be something as simple as a lithium-ion battery that you use during peak demand, or it could be something more exotic. We also like to look at smart scheduling and load reduction. And my favorite one personally is combined heat and power schemes. And this is where you actually recommend that they put a power generator in the plant. And they use the electricity for their process, but they can also use the excess heat, for a furnace or just for building heating, whatever they may need.
Okay, so at this point in the process, we have visited the plant. We have some information that we've requested from the customer that they've given us. And then additionally, we've also identified some measures. So after the assessment, this is really when we engineers can get excited, because we have to analyze the data and quantify the savings. So this is where we get to pull out all of our fancy thermodynamic equations, all that kind of good stuff, to help identify the energy savings associated with these, with the energy saving measures that we identify. And this process typically takes 4 to 6 weeks, though it can be expedited depending on the time of the year, time of whether we're in finals, nearing midterms, that kind of stuff. Typically 4 to 6 weeks, but it can be shortened. Then after that time, we'll have identified a solid number for be it electricity savings, natural gas savings, water savings, any type of utility savings, and we will present our findings in AR presentations. So this is when the whole team gets together, the team lead, the professional lead, which will either be Julie, Dr. Powell, or Ed, and we'll present our findings. And in these AR presentations, we're looking for 3 main things. Looking for the savings mechanism, which is how is this measure going to save energy? The savings methodology, this is essentially your equations. And then your costing methodology. So say that you're recommending a high efficiency motor, for example. Your costing methodology will be what resources did you use to get a cost for this motor? What labor costs are associated with it, that kind of stuff. So basically the AR presentations are meant to flesh out which parts of your AR are good and ultimately just make it better so we provide the best result to the customer. So the goal in our assessments is to come up with a minimum of 3 recommendations. And this is the minimum that will be accepted by the National IAC database. Typically, we hit this very easily. If you go back and look at some of the reports on Box, we get up to 9, 10, and even more recommendations per assessment. And one of the most critical measures that we identify in this analysis stage is the payback period. And basically, this is a basic equation. So you take the annual savings from the measure that you identified, this is in dollars, and you divide that by the implementation cost. And this will give the customer a good measure of whether or not they should implement this project or not. If they're only going to get $10 in savings per year, but it costs, say, $1,000 to implement, then it doesn't really make sense to implement that recommendation. And some customers will actually give us a specific minimum payback. So they'll say, if it's above 2 years or if it's above 3 years, then don't even mention it because we're not interested. So that's one of the measures that you'll be developing in your analysis. So at this point, once you finish the AR presentations and you've done some revisions on your calculations, that's when we'll begin the report writing process. So the report that we ultimately present to the customer has many parts to it. From the start, we start with a process overview. So this is where we place the information regarding the facility info, such as like what products they produce, where the facility is located, that kind of stuff. We also include information regarding the process description. And this is basically how they do what they do. So they could get raw material from one end of the factory, they put it through XYZ process, and it comes out a finished product at the other end. So the process description is a step-by-step kind of guide of that entire process. We also provide a list of the major energy consuming equipment. So this will typically be your large compressors, large pumps, boilers, chillers, that kind of stuff. And then lastly, in this process overview section, we also provide a best practices section. So during our assessment, our on-site assessment, we'll observe their practices generally. And a lot of times our customers are doing a lot of things right. And we definitely want to give them credit for that. And we list those in that section. After the process overview, we have the energy and waste accounting section. So this is where we summarize the energy bills and utility bills that they give us. So we'll go through their electricity, natural gas, water. If they have wastewater, we'll also put that in there. And then notably, we also get our unit costs in this section. So unit costs are dollars per whatever utility they're saving. So dollars per, say, kWh for electricity usage, dollars per MMBTU for natural gas. And those unit costs you'll end up using in your analysis for your AR saving measures. Again, we're trying to identify at least 3 ARs, and our goal is to save the customer somewhere between 5 to 10% of their total utility bills. A new section that we've added recently is the air emissions calculations. So basically, we try to quantify how much energy, how much emissions they'd be saving if they implemented our measures. And then lastly, we have an additional consideration section, and this can contain our cybersecurity. So for every customer that we talk to, we see if they're interested in cybersecurity. Some of them aren't. The ones that are interested actually get a lot of value from our cybersecurity talks with them. So we have a small blurb on that at the very end. And then also in the additional considerations, we list our ARs that we went through the entire AR development process with, but at the end they had poor ROI, so a really long payback period, or that we just didn't get the information that we needed to reliably recommend that. But we do want to take credit for the work that we did. So that goes at the very end. And conclusions, we just summarize our findings. So we pretty much sum up all of our savings numbers and present that at the very end. So at this point, the rough draft of the report is complete. And then we'll go through a team review. So all the team members will get an opportunity to look through the report, make any spelling changes, decide where things don't make sense. And that's just really as the name suggests, a team review. After the team review, the team lead will give it a final review and send it off to the professional lead. And the professional lead will be either Dr. Powell, Julie, or Ed. And then they'll give their input on the report as well. Following the professional lead, we'll actually submit it to the IEC database. And this is where we send it off to Rutgers, to the well-known university in New Jersey. And they'll give it the final stamp of approval so we can send it to the customer. And this report, from the day that we visit the site until we submit it to the IEC database, has to be within 60 days, but we typically aim to do it sooner than that, so we're not up against the wall on that. After, Rutgers will review it, and typically they're very quick with their feedback, typically within 3 to 4 days. And at this point, they can either approve it straight up, or they'll give us some feedback to change some clarifications or anything. At which point we'd resubmit, and finally, the report's approved. So after about 60 days or however long it takes for reviews, the report will be approved and we'll be all set.
So once we've gotten this report put together and we've gotten it all approved, made it through that rigorous review process, we can finally deliver it to the customer for them to read and appreciate all that hard work that you put into it. A few weeks after this, the team lead will reach out to the facility staff and they'll have a meeting. And this is just to clear up any confusion, address any questions. The primary purpose here is to make sure that they want to implement the ideas that we have. Julie, I'm sure will mention this to you, but one of the biggest indicators for an IAC, whether or not they should receive funding, is their implementation rate. So we really want our customers to accept the ideas that we have, and we want to make sure that it works for them. So this is a great way for us to ensure that they read our report and that they're interested in the ideas that we have. And at this point, we can just sit back and take a nice long breather, about 6 months long to be exact. So after this time, we contact them again and we actually see which ideas they've implemented, which recommendations they like, and if they didn't implement them, why that was. So hopefully at this point you're wondering, well, that's great. Does this actually work? And I'm so glad you asked that, because it does, it really does. On average, we recommend about $140,000 of recommended savings per year per site. I mean, that's the cost of tuition. That's incredible. Now, I mean, only 50% of that is implemented, but that's still quite fantastic. And in the end, that rounds out to about over 2 million pounds of CO2 saved per year, again, per site. So as you can see here, there's tremendous environmental impact and tremendous economic impact that we're providing here. And this really does impact people's lives in a very good way. Now, businesses, as you're probably wondering, are not the only ones who benefit from this work. You benefit quite a lot yourself. To start with, you're getting real plant experiences that you wouldn't otherwise get in the classroom or at other internships, particularly when you're talking about client interaction and technical writing. There's a lot of other things that you can put on your resume that make you really competitive. I mean, you can talk about real, $100,000 savings projects that you brainstormed, you calculated, and that you drafted up. There's a lot of bullet points that you can put under the skills section there. I'll let you come up with some more on your own. And if none of that is good enough for you, I know it's not a competition, but IAC students make about $6,000 more per year than their counterparts upon graduation. So always nice to know you're making a little bit more money. And I'd just like to finish this presentation by saying thank you guys for watching. Nestor and I really believe in the work that we do. We really enjoy it, and it has tremendous impact. So we hope that you enjoyed as much as we do, that you do some good work, and we just want to wish you good luck.